VR games are just as easy to make as normal games. Right?
Wrong.
They have so many new problems that you wouldn't even dream of when making your usual game. Virtual reality, a shining example of the future, but a pain in the arse for the people making it. You'd never expect that the ability to move your head and hands wherever you want to be so annoying. But you people just won't stop going through walls. What are you looking for out there? Normally the player collision capsule is large enough to prevent you entering any walls, but in VR, the camera is your nosy little face, so you can put it wherever you want. No boundaries with you people. But wait, there's more. You have two hands which can also go through walls, so how do we deal with that? You might think it's as simple as just giving them hitboxes and stopping them passing through. This would be fine, except it makes it feel like your VR hands are disconnected from your real hands because they're in different places. So we just let you put your hands wherever you please. Although at first it may seem weird to be able to grab the inside of a wall, it makes climbing feel much more intuitive. Because VR has depth, you need two different screens, one for each eye, which show a slightly different perspective of the world around you. This means you have to render each frame twice at a time. Due to the fact you're staring directly into the screen and can't look away, lag is particularly bad in VR. If the game runs at 50 FPS in a standard game, it's not great, but you could put up with it for a while. But in VR, 50 FPS will make you throw up. Motion sickness is not so fun. This makes optimization very important. At least for us. To achieve the insane level of optimization we desire, we used a lot of different methods. We use UV atlases, so first I'll explain what UVs are. They are a way of displaying the 3D geometry of a model in 2 dimensions. This allows you to apply 2D textures to 3D models. With this, you can manipulate the size, position, and orientation of the 2D shapes that make up the mesh to change how and where the texture is applied. This is where it gets complicated. By creating a second UV map, we can arrange the geometry of the mesh into a UV grid and then apply different materials onto the mesh in Unreal Engine. This saves having to use multiple material slots, which reduces draw calls. What are draw calls, you might ask? They are calls from the GPU to the CPU asking what they need to draw for each frame. So less draw calls means more performance and higher FPS. We also instance all of our repeated meshes, which means that every time a mesh is needed, instead of calling for the same mesh every time you need it, it calls for the mesh once and duplicates it for every position and scale used in the level. This yet again lowers draw calls. We lowered the resolution of our light maps, which are like textures which store where the light and dark parts of our meshes are. As our game uses a cell shader to give an almost comic book aesthetic, we don't need a very smooth gradient from light to dark. So the high resolution would end up being a waste of performance. For true black objects we use a null material, which means it doesn't use any reflective or lighting passes. We use texture packing, which allows us to combine the opacity, metallic and bump map textures all into one single texture using the RGB channels for each. This means that it only needs to call one texture instead of 3. It also reduces the texture file size considerably. We also use a light mass importance volume, which is the area in which the lighting is calculated, rather than doing it for the entire level, including empty space. Which is why you definitely wouldn't want to make it astronomically large, and no one would be that stupid. Finally, we use multiple levels of detail, or LODs for short. These are the same mesh with different triangle counts, as when you are far away from a mesh you don't need the maximum detail, and instead you could use a blob, which means you don't have to render so many triangles at once. So, now that I've turned your brain to mush, we'll cover some less complex problems. Normally, when you want to test features you have just failed to create, you can simply press play and use your keyboard and mouse to navigate. But this is a VR game, so if you want to test anything that involves a feature that is unique to VR, you have to put on a VR headset. Every time. This is not so fun, as putting on and taking off a VR headset 20 times in a row, and the bug still persisting, really sucks. You also have the problem that there is many different VR headsets which have different buttons, resolutions, and FOVs. There are a lot of edge cases, such as if you have both hands trying to grab the same object, then which hand moves you and which hand goes behind. We decided to simply stop you ever having both hands able to hold something climbable at the same time, which may seem strange, but feels much better when climbing. One problem we actually avoided is full body inverse kinematics, which is where the arm or leg position of a character is calculated by the position and rotation of the hand. The problem this causes is that you can rotate your arm without rotating your hand, so the VR arm ends up in a different spot to your real arm, which can break immersion. To avoid this issue, we just took away your arms. To which Cheese said, we de-armed. Somehow your brain is just fine with not having arms in VR. but having arms in the wrong place just feels bad. So, after hearing me complain about the many complex issues VR developers have to deal with, you must be wondering why we're even making one. I would be lying if I said it wasn't partially sunk cost fallacy. We are too far in now to go back. But we also find it's more interesting than your standard 3D platformer, and allows you to make a truly unique game that isn't just the same 3D platformer with different graphics. So, although at times we may hate working while everything falls down around us, it's still worth it for the fleeting moments when it all comes together.